Hi everyone, welcome to the Ontario Tech Open House. My name is Dr. Nick Ladelfa. I'm a biomechanics and ergonomics professor here in the Kinesiology program. So what I'm going to do for you now is show you a quick demonstration of what one of our computer labs might look like in the ergonomics course, which is an elective in third or fourth year. So within these labs in the course, we typically start off doing actual simulations of workplace tasks, such as this here, where you could see a drilling task. So the typical process is you would come into the lab and do physical assessments of these tasks. But then the unique component is we actually then, in following weeks, do virtual ergonomics assessments as well, using some pretty sophisticated software. Some of the research I've done has actually been incorporated into some of these digital human modeling software packages, such as Santos Human. So in this demonstration, I'm going to show you how we can actually reconstruct this task or simulate this task in a virtual environment and conduct some primary ergonomics analyses on these. This is a pretty interesting approach. It actually prepares our students very well for the real world and gives you access to some very leading edge technology. So I hope you enjoy the demonstration.
Okay, so the first thing for this lab was to just kind of get more familiar with Santos, right? So work with some of the posture prediction within Santos. In the first lab, we kind of learned some of the basic functions, right? So let me just put in a mannequin now. Right, so we learned how to import a mannequin, how to kind of rotate and toggle a camera, right? So if you hold down spacebar, you can kind of look at them, you can kind of pan in, you can scroll, right? So all these functions, and we talked about various ways you can posture the mannequin, right? They have some preloaded postures here that you can kind of slide them into, right? You can save your own postures, whatever the case may be. So neutral stand, right? You can move them within the environment using these. You can rotate them using this, right? So we kind of went through all those basic things. So within this lab, we were talking about various other types of posture prediction methods and ways of achieving that. Okay, so for example, I kind of get you in the lab to go through the actual, let me show it here, the training packet. Right, so this is material actually created by Santos, and it's meant to kind of train people in how to use these things. Right, so in this one, we're learning what end effectors are and markers are, and it kind of works you through these different scenarios. So I'll just quickly show that to you right now. So the whole idea with this is we can pull them up here. So the whole idea is Santos has very good posture prediction algorithms baked within it. It's one of the big strengths of this program compared to another. So the general idea is that if we can put some sort of a marker onto the body, so I'll zoom in here to his hand, and I'll put what's known as an end effector onto his hand. Okay, so that end effector now is kind of linked onto his body. Okay, and say I want him to grasp or move his hand forward somewhere. So one way I can achieve this is to put in something known as a marker. Okay, so I put it into the environment, but now I'm going to just put it somewhere kind of within reach. Right, so this marker is kind of out in front of his body. Maybe I'll put it a little bit more out in front of his body and higher up. Okay, and what I'm going to do is, let's say that this marker represents a point in space that I want Santos to reach to. So I'm going to right click and say pick parent, and I want to link it to this end effector. Or probably even better, pick marker target. Well, I'll pick this marker here. Okay, so now you can see that there's a line connecting these two things now. Okay, so this end effector, which is linked onto his body on his hand, is linked to this marker. So now when I go and click predict posture, computer's a little slow. Let's see how it kind of moved his hand up to there. Alright, so same thing, I'll go and pick that marker again. Zoom in on it. Okay, let's move the marker out. We'll move it higher. Okay, move it to here. We'll click Predict Posture again. Okay, and now it's kind of removed his entire posture in order to meet that up. So within the lab, we talk about various ways we can go about in doing this. Right, say that we wanted to create some sort of a surface. You can adjust that marker to be like a 2D plane. Right, so I'll show an example of that. We'll zoom in on the marker, or we'll right-click on the marker here. Okay, and instead of marker type, we'll make it a bounded plane. And we'll make it a lot smaller. Okay, let's just move this out. Oops. All right. So now you can see this marker is now represented by an overall plane here. Okay, let me make it even smaller. Okay, and I'm going to rotate this plane. Okay, and then I'll move it down. Okay, so now when I predict the posture, it's going to try to get that end effector to lock on somewhere within that plane. So it's going to predict whatever posture is kind of the most energetically efficient. We can kind of tell it exactly how it wants to predict that posture. And if we wanted to get that hand to be flat onto that plane, there's different ways we can go about doing that. Probably the most common one would be to use multiple end effectors. Right, so I could take this end effector, kind of put one on his palm there. Okay, and then put one kind of on his fingertip here. Okay, so now I'm going to also link it to this target over here. Same with this one. Pick marker target. So now all three of these end effectors are going to lock on to this plane. Okay, so you can see didn't quite work super well. If I had put that other end effector closer kind of to the palm over here, it might actually do a better job. So let's try that again. It's thinking, it's computing. There. So that's a little bit closer now. So you can see how all three of those end effectors are now contacting the plane. Okay, so this is a way that we can use Santos's posture prediction in order to posture a mannequin nicely into a scene. So now I'm going to pull up what the scene looked like for the lab. Okay, so here we have, so one of your classmates, Jaden, actually put this together. So did a fantastic job, kind of created that scene. And this is representing, if we go back to our OneNote here, this is kind of representing for station 2, the power drilling task. Right, so remember that this task involved holding a drill, kind of placing that left hand onto the surface here, right, and then doing various types of analyses here. Okay, so within Santos, we've mocked up this scene here now. You can see that the right hand, we're using an imaginary drill here, but we kind of postured the hand how that would have to look. Okay, here with the left hand, you could see that there's some end effectors there, and those are contacting onto a plane, and that plane was put on the actual surface of the desk there, the table. Another thing that you can input in terms of the posture is a visual type thing. So you can actually say, well, I want the mannequin to be fixated onto this part. Okay, so that's another thing that very much would drive a person's posture, so that makes a lot of sense. Okay, so these things have been inputted. Now we have this digital human model representing the task that we're looking at. Okay, so another important part of this is the actual hand force that we're looking at. So if we go into the end effector here, so one thing to keep in mind is that one way you can represent hand forces here with respect to the digital human model are through point loads. Okay, so if you go to the library, you would find it here within there. So it's a point load. Just like an end effector, you can attach it onto different segments of the body. Okay, so I'm going to remove this one here just to keep it nice and clean. So we're just looking at one point load. And the first part of the lab here, what is the net magnitude of the reaction force vector and what direction does the arrow point? Okay, so within Santos, it's always representing a reaction force. So the weight of the drill is kind of going downwards, and as we press upwards to apply 10 newtons of force upwards in the drill to kind of move that drill, to move that screw in, that's going to require an additional 10 newtons. So overall, the net magnitude that we need here is 40 newtons, right? The weight of the drill, 30, plus the upward pushing force of 10 newtons. Okay, so this is 40 newtons. Okay, and though we're exerting in the up direction, right, that drill is kind of exerting in the down direction. So we need to make sure that that vector, so here we can input 40, so that represents 40 newtons, but we want this 40 to be in the downwards direction. Okay, so one way that we can go about doing that is, you can actually grab onto that point load. You can kind of rotate it this way, right, using these toggles. Okay, but instead of that, a nice easy way here is you can just change the polarity of this x direction here from -90 to +90, and that'll just flip it so that the vector is going down. So now this represents the reaction force. So the drill as well as the opposing force is going to be pushing the hand in the downwards direction with the magnitude of 40 newtons. Okay, another thing that theoretically what we should do is we need to change this position to 0, 0, 0. And we want that to be, we're telling exactly where we want the point load to be. And we want it to be in the knuckle of the right hand. Right, so if we look for finger, middle, right 1, 1, this tells us where do you want that coordinate to be relative to the knuckle. And we want it to be right on that knuckle, so we're going to make its position 0, 0, 0. Okay, so now this is how you tell Santos exactly what that point load is. Okay, so it's located at the knuckle, the reaction force is in the down direction, and it's 40 newtons. So now we have this all set up for us to start running some ergonomics analyses. So me and Jim Potvin created this arm force field analysis, which has since been integrated into Santos. Okay, so what we're going to do is exit out of this joint torque visualizer, and now we're going to pull up an arm force field analysis. Okay, so same thing, it requires that same arm force, or that same point load vector, the mannequin has to be postured appropriately, and then we can open up this arm force field. Okay, so what we're going to want is to have a point load in the right hand there. Okay, and we'll apply the forces. So we want to figure out, the arm force will tell us, okay, we need to create 40 newtons here, right? So the demand is 40 newtons, but the arm force field tells us what is the 75% capable strength for this force vector, right? So what is the value that 75% of females are able to achieve in this exact scenario? Okay, so we're going to tell it we want this point load of 40 newtons to be evaluated, so we're going to apply that. Okay, and then we've selected a female, kind of standard anthropometrics here, and we want to estimate the maximum acceptable force for 75% capable. Okay, so what we're going to do is estimate the arm force. And what this is telling us is that the right arm, in this scenario, 75% of females can produce 43.2 newtons. Okay, so what does the arm force field predict the manual arm strength for a 75% capable female to be for the power drilling task? So it predicted it was 43.2 newtons. Okay, so what percentage of the population has the manual arm strength to perform this task one time? Okay, for the percent capable, we go into the left side here. And what this is saying is for 40 newtons, 79.6% of females are capable of this. Okay, so let's just kind of do a check here. So remember, we're evaluating 40 newtons. That's the force that this power drilling task is requiring. And the arm force field is telling us that the maximum acceptable is 43 newtons. So 40 is within that 43 limit, which means that this would be acceptable for a one-time exertion. Okay, and this is reflected here as well, right? It's above that 75% capable criterion. So for a one-time effort, this task would be acceptable. So a 75% capable female can do this task one time a day. They have the strength. For 1 RM, a 1 rep maximum.
So that was a short example of what some of the computer labs might look like in your kinesiology program. We certainly have a commitment to introducing some leading edge technology into our laboratory experiences and within our courses. So hopefully this gave you a bit of a look into what these might look like. Thanks, and hope to see you in September.